Ever pondered over the significance of sequence classification in digital signal processing? Well, today we delve into the heart of this intriguing concept, breaking it down piece by piece. At its core, sequence classification is a crucial aspect of digital signal processing. It's the process of identifying the class or category of a sequence of observations. Think of it as labeling a series of data points based on their inherent patterns and characteristics. This process forms the backbone of many applications, ranging from speech recognition and language translation to financial forecasting and beyond. So how does sequence classification work? The process unfolds in a series of well-defined steps. First, data collection takes place. This involves gathering sequences of data or signals from various sources. The data could be anything: audio signals, text, sensor readings, stock prices, and so forth. The key is that these sequences of data are time-dependent, meaning the order of the data points is significant. The next step is feature extraction. This is where the sequences are processed to identify and isolate the key characteristics or features that are useful for classification. It's akin to picking out the unique traits in a sea of data points. These features can be anything from the frequency of a sound wave to the volatility in a stock price. Once the features are extracted, the sequences are ready for classification. A model is applied to the sequences. This model, often a machine learning algorithm, uses the extracted features to assign a class or category to the sequences. For instance, an algorithm might classify a sequence of audio signals as speech or music based on the extracted features. The final step is validation. Here, the accuracy of the classification is tested using new, unseen data. If the model can correctly classify these new sequences based on the learned features, it's deemed successful. If not, it's back to the drawing board for adjustments and improvements. So why does this matter? Why do we need sequence classification in digital signal processing? Well, the applications are manifold. From recognizing spoken words and translating languages in real time to predicting stock market trends and diagnosing medical conditions, sequence classification is the secret sauce that powers these capabilities. In summary, sequence classification is a fundamental part of digital signal processing. It begins with data collection, followed by feature extraction. Then, a model is applied to classify the sequences based on the extracted features. Finally, the classification is validated using new data. The process is iterative and continually fine-tuned for accuracy. The end result? A powerful tool that can decipher patterns in sequence data, enabling a host of practical applications that shape our world today. So the next time you marvel at a voice recognition system or a language translation app, remember the unsung hero, sequence classification. It's the invisible hand that guides these systems, turning complex data into meaningful, actionable information.